you think about just your regular old tabletop charger, like if you have a Samsung charger or a MagSafe charger, I mean, it essentially touches your phone. But for boats, if you want to be able to put it under the fiberglass material, or if you want to put it, embedded in the boat so that it's completely impenetrable to water, you need to increase that distance. So what we're seeing in the market that we help develop is technology that allows you to go up to, I think, 15 millimeters of separation so that you can do the Qi protocol, but you're doing it through those other materials, including fiberglass or rubber or whatever the boat manufacturer wants to put in. When people are out on the water, oftentimes they're playing their music through their phone. I think that's actually more common than not, that people will use their phone to either stream their Spotify or their iTunes, or they'll have a downloaded playlist that they'll use if they're away from the cell towers. Can you talk about, how wireless charging can be there to help people from draining their battery during those situations without having to plug in an environment where there's a lot of water around? You don't really want to use plugs. So how's wireless charging coming in? What type of technology is important to have there, and why is it unique to the boating market?
Yeah, well, from a wireless charging standpoint in your smartphone, Qi is the key standard that all smartphones basically today are charging off of. So that's one of the key things you're going to have on, in a boat.
Yeah.
Now, a boat's unique in that it needs to be sealed off because it is in a very, very wet environment. You're going to be outdoors. You're going to be getting rained on and everything else.
Yep.
So you're going to need to have a seal, and with materials that the charging itself is going to have a fairly large distance inherently with it. So Qi is fairly close, so you need a solution that's going to give you a certain amount of distance associated with it and still give you a good wireless charging experience.
Yeah, so like if you think about just your regular old tabletop charger, like if you have a Samsung charger or a MagSafe charger, I mean, it essentially touches your phone. But for boats, if you want to be able to put it under the fiberglass material, or if you want to put it, embedded in the boat so that it's completely impenetrable to water, you need to increase that distance. So what we're seeing out in the market that we help develop is technology that allows you to go up to, I think, is 15 millimeters of separation so that you can do the Qi protocol, but you're doing it through those other materials, including fiberglass or rubber or whatever the boat manufacturer wants to put in. What makes that hard to do that increased distance relative to the typical 5 millimeter standard?
Well, most of the standards are built about 2 to 4 millimeters or so is about what the average is. So
touching.
Yes, yeah. So you're essentially touching. The coils themselves have a very close spacing between them. So that was something that New Current worked on with the Wireless Power Consortium to drive some new standards that have a greater Z distance, and that was some of the technology we helped drive into the Wireless Power Consortium for other customers, but it's very applicable to boats as well to help solve problems where you're able to handle the larger distance between you and really solve the problem for the boat manufacturers.
Why don't you just take the same systems that are certified for 2 to 4 millimeters and then just you spread them out by a 3 times larger distance? What kind of technology needs to go into that to enable the 15 millimeter gap?
Well, as you're expanding that distance, the coupling starts degrading, and you need to do certain things to help get that coupling back. So New Current has technology they built into the product to help drive that to higher distances and help drive that through the certification process.
I like how you say they built, as if you weren't part of inventing the solution, making it part of the global standard. I mean, so humble, but you literally invented it and then you gave it credit. I'll take the credit. But okay, very cool, great for boats. Other areas that we see related to boats, I think about RVs, I think about like four-wheelers, like Polaris equipment and stuff like that. Are there any other obvious applications for this extended Z technology as far as, like infrastructure or vehicles go?
Well, New Current has also worked on industrial handhelds that are used by more commercial products to do their own handheld industrial products as well.
Like fleet vehicles, like a UPS vehicle or an Amazon truck where they'll have a charger to hold the computer.
Yeah, and because of the ruggedized nature of those products, there's naturally a bigger distance between the coils just because they're very robust designs.
Thick housings, hand straps between them, sometimes a stylus dangling in between the transmitter and receiver.
Yeah. And it doesn't lend itself as well to the traditional Qi standard itself, so New Current has done its own spins to allow those to basically be made.
Well, great. So thank you for inventing and then giving me the credit for inventing the ruggedized extended distance so that we can listen to music on our boats or we can do them in rugged environments like delivery vehicles, because I think it's a real good enabler, and I appreciate you talking about it today.
Sure, thank you very much.